this part that I want to tell you about now, it's referring to the nested queries. When I say a nested query, I refer to a query that is having a subquery, or better said, query in a query. Where I'm going to put this subquery is going to be in a where clause, in a from clause, in the having clause, wherever you want. The subquery is evaluated when the condition from the where is tested, from the where clause is tested. I was trying to show you also this text that also appear in the document. I'm going to start with an example. Find the name of the students who are graded in algorithm 1. Definitely, algorithm 1 are not graded. Okay, so this means that I'm going to need to use my tables students and exams. Students, exams. I want to display the students that are not graded in the algorithm 1. So this means that I need to check for the students the ID of the course. Yes, and that's why I need to use these two tables. So I'm going to have this select. This select is going to use in, or in my case not in, because not graded. If I'm going to do a select like this, select the ID of the student from the table exams where the course ID is algorithm 1. Definitely this is something that I'm interested in. Yes, I have these two students that have been participated at this course that it's called algorithm 1. So I don't want to see the name of these students. I want to see the name of the students that were not there. So this means that the ID, the students with the ID 1234 and 1235 are on this course algorithm 1. And that's why I'm going to have a subquery. I'm going to display the name of the students from the table students that does not participate in this course. How I'm doing this? Very simple. I can make use of the SID that I'm having in both of the tables. With other words, I'm checking if the ID of the student that is here is not in this set. In, respectively not in, is checking if a value can be found or not in a set. In our case, is checking if it's not found in that set. So it's going to take the IDs, the name of the students that have the ID, not here. Definitely it should show me the student that does not have these two IDs. If I'm checking on my table, students and exams, more exactly, I think it should be enough if I'm showing you in the table exam, because are the others that do not have the SID mentioned by me. So I'm going to have the others are 1236, 1237, and 18. Let's execute the entire query now and check the results. And of course, these are my 3 students. I'm sorry, I forgot it was about the name. That's why I'm going to come back. The students are the last 3, the ones that I've told you. And if we check here, are Monica, Paula, and Alina. And if we execute again this query, of course, that the result is the same. Monica, Paula, and Alina. Is it quite okay?
Yeah.
Okay,
Yes.
thank you. Next, to be honest, I wanted to make a little easier for you because I already know what we want to display, and I'm going to rewrite this query but equivalent with exist. In my case, it's not exist. How I'm going to do here? I'm going to select also the name from the table students where not exist. So I'm not going to check any longer that my value is in a set, respectively is not in the set. I'm going to check if this set is non-empty. Okay? And if I'm trying in this case to execute separately the queries just to show you what are we going to get, it cannot be. Why? Because here I'm checking not exist, but in not exist, from this not exist is returned in the brackets a set, a table more exactly. It select from exams E, and the condition from here, it's not using only the table exams, it's a connection between the table exam through the SID and the table students from SID. And the table students, it's not available here. We don't have in the bracket select the table students. We have the table students only outside of this parenthesis. And that's why this query is not going to work by themselves. It's going to work only combined. So these are the nested queries, the first one, the second one, but not all of them are working separately. So it's not like all the time you can check what is in the parentheses and if it's work, you move on. There are some queries in which by dependencies are going to work only by entirely. And of course, the condition of the algorithm one. So I'm going to execute again this query. Again, in the sense that is the same result, of course, it's returning the same things. And this is how it happens. Okay, as a short conclusion, the in operator is the one that is testing whether a value belongs to a set of elements, as we already have said. And the exist operator is test whether a set is non-empty. Okay, so this is the big difference between these two operators. But also you're going to have some examples to prepare for the homework in the laboratory too. And also I have more examples on the laboratory, on that laboratory. Okay, if you have questions until here. Okay, um, next I want to tell you something related to the operator that is called any and all. When am I going to use any? The operator any is going to be used when the value is true if the condition, well, the value of this operator any is true if the condition is true for at least one item in the subquery result. In the case of the all, the condition must be satisfied for all the items from the subquery. In other words, in the example, I would say it's better to understand. I'm having this example. I want to find the students that have the age greater than the age of some student called Yon. So with other words, I'm going to make a comparison. Okay, and on the second one, I'm going to have find the students those age is greater than the age of all the students called Yon. With other words, I will start with the second one because it's more simple. Find the students those age is greater than the age of all the students called Yon. If you have more students in your table Yon, you have to compare the age of the students with all the age of the students that are called name. It's something like comparing with the maximum age of the student Yon. Let's suppose we have 4 students that are called Yon, and one has the age 22, one 20, 21. Definitely the value to which you are going to compare is going to be 22, so the maximum, because it has to satisfy be greater than all the ages of the student Yon. And all the ages of the student Yon are 20, 21, 22. So more exactly, what I'm interested is to check that maximum value. And to check that maximum value, I can use this all. Okay, it's something like select star from the student where the age from this table student is greater than all the values, all the ages from the table students that have the name Yon. Okay, it's something like this, but if we try to understand, is the maximum value. Okay, so the comparison is going to be done with all the values that appear there. It's if we want to write equivalently, the maximum is the solution. I don't have Yon. That's why I comment Yon, even if the request is with Yon, and I have Ada. Um, these are the students. Just one moment. I want to show you what I'm having in the table students so that you can understand why I have these values. I have these students, and now I make the comparison. The age, Ada has the age 21. Yes, yeah, sorry, Ada has the age 20. And which are the students that have the age greater than 21? I'm sorry. I have the student Ada, and Ada has the age 20. So I need to display the students that have the age greater than the age of Ada, of all students at Ada. So the conclusion is that the students that are going to have the age greater than 20, that's the age of Ada, are going to be Razvan, is having 21, and Italina, that is also having 21 years old. And if I'm going to execute again, you should see here Razvan and Alina. Okay, this is the all. And if I want to say you about the any, it's greater than any. And if I'm going to execute this one, what are we going to obtain? And we are going to obtain the same result. In this case, not all the time is the same. Find the students whose age is greater, because the age has to be greater than the age of some student Yon. Usually here it's taken the minimum. If I was having Ada with 19 years old, of course I should have had as a result also the students with the age 20. But I have Ada that is having only 20 years old. That's the only one. So definitely I will have just the one that have the age greater. Greater than 20, of course, it's only 21. This is like these are these operators. These operators has to be tested all the time for the cases and see how are working in that specific case. And only by testing them you can you can have you can have a better understanding of them. We can have more discussions here if you want on the laboratory also, but if you have questions now you can tell me. If not, I'm going to move on, and I'm going to tell you something about the join, more exactly about the inner join, the left outer join, right outer join, and full outer join. Okay, from the beginning, I start telling you about the relations that we have between the tables and the connection that we should establish all the time between the tables that we have. When we establish these connections, when we want to display, for example, what we have here, we don't have a request, no problem. Let's say we want to display the students that have the students that have participated to the courses. With other words, I want to display the students that are connected to the exams and also to the courses. Usually I can do this in two possible ways. I'm going to connect the table students with the table exams. I'm going to make the connections through the SID from the students and the SID from the exam. Students.sid equal with exam.sid. And also, if I want to continue, I need to verify the condition. The ID from the courses must be equal with the ID of the course from the exam. Courses.cid equal with exams.cid. These are the conditions that should be all the time satisfied. And if I'm coming back, I have this query. Until here, this is how we know to write it. I'm having the name of the students, the name of the course, the students, from the table students, exam, courses, and of course the two conditions that we have already mentioned. Do you want me to show you what I'm having in my tables, or it's quite okay for you? I think it's quite okay for you. I don't have all the combinations. If you want to check, Ada is on algorithm 1. The course Ada is also on MIP 1 and also on MIP 2. I have Razvan in algorithms 1 and I have Paula in databases 2. The answer, the result is correct, believe me. But I can write this query in an equivalent way by using this inner join. And usually I recommend to the students and also to me to work with this inner join. Usually the where is used to put condition like check the age, check the name, and conditions like those. But when I want to make the connection between the tables, this inner join is exactly what it's doing for us. It's another way to write a query. I'm going to have select the name of the student and the name of the course from my table students, and I have inner join exams on, and I put a condition students s exam e students.sid equal with exams.sid, and then I continue inner join with the table courses, the course id from the exams equal with the course id from the courses, and I can have as many inner joins as I want. If I want, for example, now to have another inner join in which I'm going to check that my table students is connected to the groups, it's perfectly. I'm going to have inner join groups G on s dot s group equal with G dot s group, or how is it the name of that primary key. So you can have as many as you want. The only condition is all the time to put a table and to connect that table with a table that was already there. It's not important, as I've showed you, if I connected the first one with the last one. The connection to exist. Primary key equal with a foreign key. So this is how is the inner join going to work like. Of course that the result is the same, and this is the connection between the tables, and of course not null. Do you have questions until here?
No.
Inner joins. My next one is left outer join and then right outer join. What is the difference between inner join and left outer join? All the time you need to, I'm going to consider first this students and exam E, just that part. You have the inner join like in the middle. The table that is in the left is the left, is you have a table in the left and you have a table in the right of the inner join. When you put left outer join, then you are going to take everything that you have in the table that is on the left side, even if you don't have corresponding values in the table that is in the right side. With other words, you are going to consider all the students, even if those students were not on the exam. Equivalently, all the students, even if they have the null value on the exam. Let me show you, and of course correspondingly we'll continue. I will show you here. It's the same if you have more tables. So these are all my students. As you can see, not all the students were attending the exams, and here you can a better view. More exactly, I have all the students, but I have students that have null on the position of the course name, meaning that those students have not participated to those courses, but they exist there. So this is the difference that exists between the inner join and the left outer join. So all that you have in the table that is in the left part of the left outer join connected with what you have in the right side of the left outer join. And sometimes you can have null values. So you have these values that are more than what you were supposed to have on the inner join. And when we talk about right after join, it's exactly the opposite. I will show you. this one. Now I'm going to take everything that is the table that is in the right side, even if you don't have values or you have null on the table that is on the left side. Yes, it's true, it's working. Well, not all the time you're going to have null values in a part, but this is how it's working. If there are null values, so uncorresponding values, the values that are not connected, you're going to have null. But even if you don't have null, yes, that right outer join or left outer join worked perfectly. Okay, because this is the definition. But in this case, we have example for all of them so that you can have a better view. So I have all the courses, and indeed, there are courses in which I don't have students. Yeah, it's possible. And that's why I have here null. Okay, and if I want to consider also the full outer join, for this full outer join, I'm going to have the reunion of all. I have left outer join plus right outer join. And of course, inner join. Inner join is included in all of them. The connection is all the time there. You can see that I have null also in the right part and also in the left part. So the ones that are in the right part are the left outer join. This one is from the right outer join, and the ones that are communicating are the inner join. So these are the joins. You are going to see which of these you are going to use. It depends on what you want to do. The observation that you have here on the document is exactly what I've told you in the beginning, that this writing with this writing is equivalent with the one with with where. Okay, but I'm going to execute it to know for sure. The following queries returns the same result. So you have here select star from students, inner join exams on this condition. This is how we write it with inner join, and how we write it without inner join. Select star from students, comma, exams where the ID of the student from the table students is equal with the ID of the student from the table exam. So are equivalent, exactly as I showed you in the beginning. And of course the results are the same. The advantage that this inner join is given to us is the fact that can I access all the fields from different tables, and I can update everything that I want. And more than sure your queries are going to use inner join, because without it we cannot connect the tables. This is the only possible way. Even if it's not on the seminar, I want to show you this cross join. This cross join has nothing to do with the inner join, believe me. Uh, Also, I'm going to remember this cross join to you in the moment in which you're going to have to prepare the homework number 4 for the laboratory. If you want, for example, to generate the Cartesian product of two columns, let's say you want to combine all the students' name with all the courses ID. Of course, I don't have all of them in my table, but if I want to generate something like this, all the possible combination, I can do this by using the cross join. What do I need? To put the name of the tables, and in the middle to put the cross join. And it's going to combine all the names of the students and all the ID courses. What is nice, because if you use this cross join, you can generate all the possible solutions that you can insert in that intermediate table from the relation many to many. If you set that one to be foreign key and also primary key, like in this example, if you want to put in the table exams or the possible combination, all of them, you can do that by using the cross join. It can generate to you, if you put, let's say, select SID, comma, CID from students cross join courses, you are going to have all the possible combinations for SID and CID. This was just like a parenthesis. I thought it would be nice for you to know.
Yeah, we don't even have to write cross join because if we just go over it, it would do a cross join if we select from students and exams, right?
Yes, yes, that's also right. But yeah, that's also right. Yeah, indeed.
It's better to write cross join because it's more verbose and you know what actually happens there.
Yes, yes, it's and what's nice with this cross join is the fact that you can save the result in a table or you can insert it directly on the table. And well, this you can do with all the results that you obtain as a query, but especially on the cross join because it really helps you if you want to generate all the values very quick and in a short code, it's almost instantly. Well, if there are a lot of records, it will take some time. But for you will take less time to write just 2 lines. Okay, so I think I think I can move on. I still have a part to present to you now. Um, this part that I'm going to present to you refers to the aggregation operators. The sorry, the aggregation operators that you are going to use are count, sum, average, max, and minimum. Of course, these operators are going to be applied for a column from your table or from an attribute. The only one can be applied for a star for all the fields. It's the count because count. What is doing the count is returning you how many records you have in the table. For example, select count from student is going to return me the name of the number of the students. Okay, so let me um, let me start with these ones. I will have here maybe a longer discussion. Uh, First query: compute the total number of students. Let me check what I'm having in my students table. I have 5 students, and how I'm returning the number of the students. Select count star from students. If I'm going to do it like this, I'm going to have 5 students. And of course, no column name. If you want to put a column name to this result, you can put it select count star as, and you put a name for that column. Only it is looking better, but to be honest, that name is not helping you with anything. More than this, if I want to move on, of course I can do this for any of my aggregate functions. So I'm going to give you another example here. I'm going, let's say, to select the count. I want to to make the count of the group in which I have students with the name Mihai. I don't have Mihai, and that's why I used Paula. Okay, I want to count how many groups, uh, the number of groups that have at least one student called Paula. So if I'm going to have Paula in 9 to 1 and also Paula in 9 to 2, definitely I'm going to have 2 groups. And that's why the count can be applied also for star for everything that you have in the table or for a specified column. But when you use it for a specified column and you don't put a where condition, the result is going to be all the records that you have in the table. And that's why it's a little particular than the others. I can show you what I'm having in my students if you want. Well, I've already showed you, but I need to show you once again because I have also other operations too. Paula, she is the only one. I don't have 2 students with the name Paula or and more than that to be in different groups. Okay, next I want to show you this query. We need to find the average and the minimum age for the group 9 to 5. Sorry, 9 to 4. How I'm doing this? Select the function that is going to calculate the average is the average AVG of the age because I want the minimum of the column that is called age. So average of the age and also minimum of the age. This is how you can apply these functions. Where the group ID is 9 to 4. Let me execute this one. This is the result. I'm sorry, I should have said something here. I have my ages are not very different, and that's why the results are quite similar. If I would have had here like 22 or 19, then the result could have been changed. But the average of these values are usually it's really 20, and the minimum it's 20. I have 20, 21, 20, 20, 21. Definitely the minimum is 20. So the result was correct. Now I still have this because that was the question and the discussion related to this thing. I should have showed you this also, but I didn't. I didn't see it. So if you want to use this count this thing of a column, in our case it's going to be exactly the same. But let's suppose that you were having Paula, another student with the name Paula, in the group 9 to 4. Okay, you don't want to count that Paula name twice from that group. You want to count it only once. And if you use this thing, that one is going to be possible. It's going to count only once. So distinct group to appear one in just one. I don't know how can I say it to be more clear. So let's suppose you have Paula twice in 9 to 4. When you put this thing, it's going to take it only once because he found it, and it's going to take this thing just once. But you also have Paula in 9 to 1. So this is going to be another plus 1 because you have in the 9 to 1 Paula, and you also have Paula in 9 to 4. But if you were having 9 to 1 Paula, 9 to 4 Paula, and 9 to 4 Paula, without distinct, would have been 3. Okay, this is the difference if you put here a distinct. I don't have so many Paula, and of course, the result is just 1, exactly how it was before. Okay, you don't have to just work too much with these ones. I will show you immediately with what you should work. The problem is when I want to associate these aggregate functions with what is called the other fields from the table. That's a problem because if you want, for example, to find the name and age of the oldest student, of course, that your first question would be select the name of the student, the maximum age from student, or select. If you ask me, I would have think about this answer. Select the name of the student, the age from the student where the age is equal with the maximum age. I think it's quite obviously because I'm doing what I'm asked to do. Is the age equal with the maximum? Yes or not? Well, unfortunately, as you're going to see, no chance. You cannot do it like this. These aggregate functions have some properties that you need to respect. Are how are going to be used. I will show you to convince that are not working. For this query, you can do something that is called a nested query, and it's going to work, but not all the time it's possible. How I handled this situation. I'm going to have a select in which I'm going to take the maximum age. I'm returning the age that is the maximum one. It's 21. We already know this. And I checked which are the students that have this age, this maximum age. I cannot say it equal with the maximum because it's not going to be okay. Why I'm putting here age equal with any? Because this select is going to return you the maximum, but if he found that maximum from multiple times, you should take one of the value that are maximum. You want to return to make the comparison with one value, and to make sure that is one value here, you should have this any. How I did it? I select the name, the age from students where the age was equal with one of the values that were returned here. But what I'm returning here, the maximum of the age. Of course, I need to use here again the table students, because this is, as you could see, this is another select. This is a select that is returning me a maximum value. Okay, and this is possible. The persons that are going to have 21 years old, if I'm not wrong, are Razvan and Alina. These these values that you are seeing here in my tables are exactly the values that you can see on that PDF. Okay, so it wasn't my idea to put exactly those values. I'm referring especially to the SID, because if it was for me, definitely I would have taken some easier values. So, so this is the first discussion related to the aggregate functions. Please tell me if you have questions. Okay, if not, on the on the seminar there is just one question, one query left, and this one is related to the group by. In the moment in which we want to associate it, as I told you, the aggregate function with the fields from my table, with a field, with multiple fields, you are going to know what you need. Then you can do this. But how you can do this? By using the group by clause. In other way, it's not possible. So I'm going to explain to you this requirement. For every 6 credits course, find the number of grades and their average. Of course, for each 6 credits course. Here you have the select the ID of the course from exams. Course is where the CIDR equals and the credits is 6. In this example, I went with the where clause as it was on the seminar PDF, and I have DB2. This is the course that is having 6 credits. My problem is that I need to display these courses, but I need to display also the number of the grades that are on that course and their average. So for this course, I need to see the number of the grades and the average. With other words, I need the count and I also need the average. And I need the first column to be this CID. And if I'm going to try to execute it without the group by, it's going to be an error, because the aggregate functions are contained in a group by list. And if I'm going to try to execute it by the group by, of course it's going to be perfectly correct. Okay, why do I need this group by? As you can see, the field that I'm using in group by is the ID of the course. Definitely this ID of the course can be found multiple times, and for each ID of the course, so for each these values, I'm going to group. I'm going to find this course ID multiple times, and I'm just going to take each ID as a reference, and for every CID I'm going to count. I'm having, let's say, 4 courses, so I'm just putting here as on the first column the name of the course. I'm checking 1, 2, 3, 4. Okay, are 4. Here it's going to be 4, and the average, I'm going to make the average of those 4 marks that are corresponding to this course. Okay, and I'm going to have here, let's say, 7. Not important. So it's going to group on a field that you're going to put there. You can put, of course, more fields if you want to have more fields. But it's going to do for each distinct code that is going to find. Maybe if I'm telling you something like the groups and the students. In a group there are multiple students, and for example I want to display for each group the average of the marks. It's something very classical. Of course I'm going to have a group by, and I'm going to group by the GID, the ID of the group. for how it's going to work for each ID that is going to find to be unique is going to make the average of the marks. So 921, the average is 9.8. 922, the average is 9.9. Okay, something like this. He's going to give you that column that is in the group by only once, and for that group is going to perform the operation, is going to make the sum of all the elements that is finding for 9 to 1 in the beginning, or the average that is found for 9 to 1, or any function that you are going to put after here, after the field that you want to group by, after here. On this list you can have only one, and it's doing this for each distinct element that is going to find. It's something like this, but here you need to start trying and having some exercises to understand better, and you can also ask me. Also, I need to tell you some rules that you have to respect in the moment in which you work with group by. As I already told you, if you have here a field, you have select CID and as many functions, as many aggregate functions as you want, it's okay. But if you don't put in the group by the same things, is not going to be okay. Just one moment. I wanted to start with this one because it was the most obviously one. I will show you all of them. Yes, this one. Okay, so I have the CID and I have the name. So I want you to know that it's exactly the same requirement. I'm just trying to tell you the errors that can appear. You have CNAME, you have CID, CNAME, but on the group by you have just CID. It's not okay. All the time, if you have in the select two columns, you have to put also in the group by 2 columns, and of course the same columns. Okay, so if I'm going to have also here the name, definitely is going to be okay again. More than this, if you want to put a condition related to an aggregate function, I show you that one with the maximum. That condition that you're going to put, it's not going to be put in the where clause. For example, I tried to put the condition that the average of the grades be greater than 10. I know it doesn't have sense. The idea was to test a condition related to an aggregate function. And then I put that condition on a where clause. No chance to work. But if I'm going to try to put the condition in what we call having, yes, it's going to work. And it's perfectly. It's not greater than 10, that's why I don't have result, but it's correct. So what is the rule? When you use group by and you want to put a condition to an aggregate function, count, minim, maximum, average, sum, you need to put that condition in a having clause. Having clause, it was created especially to treat this kind of conditions. If you want to try to put in a where clause, in a having clause, a condition like, I don't know, CID equal with DB2. Yeah, it's going to work also. But this is not the purpose of having, because for this one, you have what is called where. And I would like you to have like very, very good lines on this one. You have the select, you have the from. After select, you have the name of the fields that you want to select. Then in from, you have the name of the tables. In the where, you're going to have the conditions that are referring to the columns. I don't know. The grade, the grade to be less than 10, of course, or the name start with the letter, any condition. Then you have group by. When you want to use the aggregate function all the time, you need to use group by, and if you want to put a condition on an aggregate function, you are going to use having. this is the order. This is how you should perform and think about your queries. And I think this is almost everything that I wanted to tell you related to these examples. Tell me please if you have questions. Okay, if not, and if you haven't uploaded on that section that is called lab seminar to underline attendance, a file, please please upload a file there, and if it's possible, put on that file a name, your name more exactly.
Okay.
Okay, so what can I tell you? Thank you for being here. Thank you for being so patient and listening to me. And I really hope it's clear. If not, you can ask me. And more than this, on the here or on the laboratory also, we are going to have time to discuss more about these kind of queries. But if you don't have any questions now, from my point of view, we don't need to stay any longer in this call. We can end the call and it's okay.
Okay, then. Have a nice day. Bye.
Okay, thank you. Have a nice day too.
Bye-bye.
Have a nice day.
Bye.
Bye.
Thank you.
Have a nice day.
Bye.
Bye. Have a nice day. Bye.